Okay, and time is up, right? So that was 20 minutes of doing. You should have done at least, let's say at least, okay, at least 4. That means you should be at 37. Okay, question 37. So if you're not at 37, number 1, you either are not reading fast enough, or 2, you're not writing fast enough, right? The answers are not coming to you fast enough. So what's going to happen if you don't have enough time during the exam? Towards the end, you'll rush. You'll anyhow write answer, guarantee you. Okay, towards the end. And then number 2, you don't have enough time to check, so you don't know whether you got correct or wrong. Okay, so that's why we are training to write fast. Now, when I say write fast, doesn't mean you anyhow write answer. Yeah. Okay. So, but it takes a while. So one of the things I mentioned just now is for you to write fast, you can actually start. You see, this is. Let me just give you an example. So in this question, there's this couple of sentences and this picture, and there's a question. So one suggestion, right, is you can start by reading this first. You read this first. State the difference. Observe when the milk flowed out from a tin with 1 hole and a tin with 2 holes. Right? Before you read the whole thing, because chances are you will be able to answer this even without reading this whole thing. Okay, I know some of the school teachers say, oh, you gotta highlight, underline keywords and all this stuff, right? Highlight, underline. But there's a problem with doing that. There's not enough time. Can you, I mean, if by the time you finish highlighting, underline everything, right? Maybe not enough time. Then you start to panic. When you start to panic, what happens? Anyhow answer, right? Answer can become wrong. So that's not what we want. Okay, we want fast and swift and accurate. So let's take a look. So you see, let's take a look at this. State the difference observed. So this is about observation. When the milk flow out from a tin with 1 hole and a tin with 2 holes. So here they're talking about which one is faster. So if there are 2 holes versus 1 hole, right? Which one will be faster? Is it a 2 hole? Yeah, 2 hole will be faster. So we will write over here. The milk will flow out faster or the tin with 2 holes. You don't explain because the explanation is at the next part. You see, explain your answer. Why is it that when the tin has 2 holes, the milk will flow faster? Now, remember I talked about the start end technique a long time ago. Remember? No. Yes, expected. Do you remember? Start end. No. Do you remember, Ashton? No. Do you remember? No. Kenny, do you remember start end technique? Yes. Okay. Finally, at least 1 person. Okay. What is the start end technique? Now it's the expected order because I mean we did this many months ago. So we need to keep repeating, okay? And it's my job to keep repeating, and it's your job to remember, okay? So what do we do? What's the start technique? Start technique means there's a start and an end for the question. So what is the start here? You see, they say explain your answer. Explain what? Explain why is it that when there are 2 holes, the milk flow faster. Right? So we're gonna start with this. So letter S for start. This will be end. Start with when the tin has 2 holes. Okay. Now I would like to hear your answers first, right? Princess, what's the answer? Give us your answer. We start with when the tin has 2 holes. Okay. What happens when you have 2 holes? I mean, not you, the tin. When the tin has 2 holes, what's so special? What do you write? Can you tell me? There's what? Air entering. Okay, and then? That's all. Okay, next one. Please, Tristan. When the tin has 2 holes, what happens? Very good. Okay, so that's the answer we're looking for, right? So when the tin has 2 holes, and from the surrounding can move into the tin and help to push up the milk from the inside. Comma hence. So we need to end, right? What's the ending? Hence the milk will flow out faster. So the idea here is there's something pushing it out. No? The air going in is pushing it out. You understand? Right? So therefore, the milk will flow out faster. That's the idea. Okay, can you see? Is it big enough? Not big enough. Like that? You want to see here? Don't want. Okay, wait. I think I can choose size. Yes, bigger already. Thicker marker. Right? I choose the thickest marker. Okay, push the milk out from the inside and it will flow faster. Okay, so this fully explains why it will flow out faster because there's another push. Instead of waiting for gravity to pull, right? Because if there's no hole, what happens is that the gravity is just pulling on the milk. But now you have a hole at the top, the air goes in faster and it's able to push out the milk. Okay, next one. Okay, so Gina then bought a sealed packet of milk and placed inside a car. Shown both the packet and the milk have a volume of 300 milliliters. Sorry, both the packet and the cup. So what property of liquid enables the sealed milk to be placed? Kenny? Okay. Yeah, so liquid has no definite shape and can take the shape of the container. Alright, so it takes the shape of the container. The liquid has no definite shape and it can take the shape of the container. Okay, so that's why you will fill up the cup. Okay. Next one. Okay. Okay, so next one. Let's stack some wet place one on top of the other, let it dry. State two reasons why the wet place diagram 2 will dry faster. Which reason is your answer? So this one will dry faster. If you stack like that, well, it's not going to dry faster. Let's have the well. What's the answer? It's okay. Say. Very good. This is everywhere. Yep. Because more exposed surface area, water, evaporate. Okay, so most of exposed surface is one. Now the other one is the water can drip off the plate as they place vertically, right? But diagram cannot. Okay. So the one in diagram one, let me just show you the diagram here, right? See, one more time. So this has a bigger exposed surface here. Number one. Number two, the water can drip off. Water can drop off. Over here, the water cannot drop off, right? It's just stuck inside there. Okay. So water can drip. This water cannot drip. Here, you only have the top that's exposed. This one, there's more exposed surface here. Okay, so we can see. Is it okay? You copy? Copy already. Good. The water in diagram 1 cannot. We can't drip out, they're just stuck in the puddle. Okay. Let's do the next one. So many about dish rag with a plastic cover sheet. Okay, how the water droplets are formed? How come water droplets are formed on the inner surface of the plastic cover? Right. So this is an explain question, right? So we have a start at the end. So what's the start? I'm gonna put that at the end, right? The start is here. Not a dish rag with plastic cover. There's a plastic cover, right? So the end is here. How come water droplets will form? So you gotta start with this, right? Where there's a plastic cover. Okay, actually, you're gonna try. Just tell me.
The water is like going to form a plate and form on the plastic cover.
Oh, see how we marks 2 marks now? You're gonna get 1 mark only. Okay, a lot of missing stuff, right or not? There's a lot of missing things in between. Vincent, wanna try? Okay, so this is where you lose marks. You understand? Can you read out what's yours? What's your answer?
The water on the wet plate evaporates
Mm-hmm.
and form on the plastic cover.
Yeah, also 1 mark. Please, listen. 1 mark.
The
Oh.
water from the wet plate evaporates and condenses onto the inner surface of the
Okay, condensation, but still don't have full marks. Okay, what's missing? What's the whole condensation process? Yeah, then you must touch the what? Cooler. Did you say cool? Did you say cooler surface? You never say. Must say cooler surface. Right. So I tell you, condensation is a guarantee come out. Right. Condensation. Every year there's condensation. Every year I make the same bet with the physics student. You can ask your brother. I tell them if condensation don't appear in your PSLE question, right? I'll buy everyone Happy Meal. Everyone will get, okay, you don't have Happy Meal, maybe you get a burger or something. Every year I win. Because every year there's condensation and every year the same thing comes out. You know what I mean? Right? It's always condensation, right? So you need to learn how to write. So I'm gonna write it here, okay? So the start was there was a plastic cover, right? Okay, so the plastic cover. You start with the plastic cover. Oh no. Okay, no, sorry. I want to say the water evaporates. The water evaporates from the plates and comes into contact with the cooler plastic cover. Okay, to stop. They will lose heat and condense into water droplets and water droplets. Okay, so the process is always the same. Water evaporate or the water vapor evaporates. Must touch something cooler, right? Comes into contact with the cooler plastic cover. After touch the cover must lose heat. Then this whole thing is called condensation, and therefore the water droplets are seen. Okay, we will see this every week, right? Until PSLE. Every week you will see condensation, right? I mean, not every week, every 2 weeks, right? You will see condensation. Why? Because it's in every single paper. Everybody tests condensation. So please know, In fact, now you don't know. By the time you are done, which is like somewhere August or by June, right? You all will know already. All of you will be like, condensation again. What's condensation? Oh, you want to evaporate such a person, right? We keep doing this again and again and again and again and again until everybody knows that. Next one. Okay, can I move on? No, not yet. Are we ready? So next time condensation better know, everyone, better know, condensation, no, we're gonna repeat. Anyway, we'll repeat again, okay? Next one. Oh, what is this? Okay, so using a switch and some wire computer. Wait, did they copy the thing already? What in the world? Subject? Huh? They already asked the question.
No, I never.
Complete the circuit in the diagram so that the camera will work as described above. What is it supposed to do? To take a picture, the camera shutter needs to be connected to a closed needs to be connected to a closed circuit with the button being pressed down. With the button pressed down, then close circuit. A photograph can also be taken by the camera with or without the flash. Okay, so this one pressed down, so you connect, right? So here must connect to here, right? Okay, so let's say you don't want flash, it must be connected here. So let's say you don't want the flash. When you press this, it must work. So at the same time, right, this must work as well. So you have one line come here, one line come here. Okay, so if they close this switch, then the flash will work. If they don't close this switch, the flash will not work. That's all. Okay, somewhat there, right? The answer is somewhat, right? Okay, suggest a disadvantage of the circuit. So what's the bad thing about this circuit? What's the disadvantage? No, this is a parallel, no? Parallel. Parallel is okay. If the bulb isn't working, the camera will still work, right? The shutter will work without a flash. Okay, what's the disadvantage of this circuit? Yeah. Any answer? Kenny, any answer? No, Tristan? No? Ashton? What is a disadvantage? Parallel circuit. Yeah, this one actually uses more electricity because it's not parallel. Okay, so I mean because it's not series, so we will just say it uses more electricity. Uses more. So if the metal pieces are switched to plastic, will the camera still work? What metal piece? This one? Of course not. No. Okay, why it doesn't work? The plastic is not a conductor. Okay. Right, so if you use plastic, which is an insulator, it does not connect electricity, it will not have a closed circuit. Okay, you get an open circuit. So open circuit, it will not work. Is it okay? Listen, quickly copy. Poor conductor. It's not a poor conductor, it's a non-conductor. So cannot wrong. You cannot write poor conductor, it's the non-conductor. Poor conductor means still can conduct a little bit. Okay, but plastic is totally zero, nothing. Okay, so the insulator. Next one. Okay, next. Okay, let's read the question. Name one suitable material for object X. What is object X? So it's supposed to be a magnet, right? Because he wants to repel the thing. Okay, so what's the suitable material? Just magnet. Because only magnets can repel. Okay, you can't use any other material. Actually, what the car with object X was pushed back along the track when Janice released it. Wait a minute. Janice cut object X. Along the car one straight line. Distance P. Yeah, first a minute, okay? So why the car was pushed back along the track when Janice released? So what's the start? The start is when Janice released. Okay, the end will be why the car was pushed back. So we start with when Janice released magnetic force backwards. Is greater than the friction. Now, where is the friction? Where is the friction instance? Where is the friction? Yes, question? Huh? Yeah, plastic friction in the wheel, right? So if the friction is more than the force of repulsion, will the car move? No, the car will not move. But in this case, the force of repulsion is greater than the friction, right? So therefore, it is able to move backward. So most students will have we just talk about magnet, right? Repulsion, that's all they will say. But the idea is that the pushing force is greater than the frictional force, and therefore it will move. So what's the relationship between distance P and distance Q? Distance P, what distance P? Q, P. We say that the smaller the distance P, the smaller the distance so it's an inverse relationship. That means if you push it nearer, the nearer you So just repeated experiment is a system of increase the distance p instead. You observe that at certain p the car did not move at all. Why? So distance p is this thing. Right, so he pushed this thing back slowly. So when you push it back slowly, obviously the magnetic force is not so strong, correct? Right, because the magnetic force is here and then there's a magnetic force here. So how do you answer this? Explain. So you can start. What's the start? We increase distance p. Right, so we say when distance p the magnetic force decreases the certain distance is 0. The distance, the force of repulsion gets weaker. So it decreases until a certain point that it becomes 0. Okay, so because at 0, you put your hands, because there's no force pushing it at all. Okay, there's no force pushing the thing. Next one. So this is okay. This will not move, right? Will not move. Okay, so 37. Right, so just now 20 minutes you should have done until here, right? So let me go through this. So name the two types of forces acting on the wooden block as they slide across each material. These things sliding across, right? So the two forces, first one is frictional force. What's the other one? Yeah, gravitation. Okay, so we get frictional force and gravitational force, right? Based on the last result, which material is the smoothest? Number of ways needed to cause the block to slide, only 3. So it's object Z, material Z. Okay, why? Why? Because a small, the three, no more weight. Three ways to cause a wooden block to slide. So the least amount of force is required, which means that the friction is the least, and hence because it has least friction. Okay, time's up, right? Let's go through last 3 questions, right? Then we'll do the next one. Should we finish this pretty quickly? Now, these two forces, okay? So, say the force which allows the diver to jump off at point A. So, it's about force, okay? So, don't talk about energy. Just I forgot I saw who talk about energy. So no energy, right? It's force. So what type of force? Elastic spring force. Okay? Elastic spring force, not elastic potential energy. Okay? If you write elastic potential energy, zoop zoop, is wrong. No frictional force. Cannot gravitational. Gravity pull down, this one jump off. Will you up, go up, not down. You understand? Okay, it's not gravitational force, right? Gravitational force is at sea. You see, this person is so straight on, like a ruler like that. But hair also never drop down. We're going so fast, right? Okay, without changing the spring force, what can the diver do if he wants to reach a point higher than B? So the key one here, don't is not. What you push it there? Don't change the springboard. What can you do? Anyone? Use more strength to do what? Jump off? No. Oh, listen. Cannot change springboard, okay? What do you do? Yes? Push harder. Push what? Push what? Push springboard harder. Between the leg and the springboard, right? That means go down further, right? What I'm trying to say is this one go further down, then you go further up. Correct? Right? So that's right. That's elastic spring force. Elastic spring force is like that. The more you pull, the longer you pull, the further it will fly. Okay? That's the idea. So without changing the spring force, what can the diver do? So the diver can jump higher. It's not jump higher. What is this? Someone say something? Yeah, alright, so jump on the board few more times to make it lower before jumping off the board. Okay, so actually that's what most of the divers do, right? They jump, doing. It's not to test the board, no. It's so that they can go lower. Every time they go even lower, and then they jump off. They make it lower before jumping on the board. Make it stretch lower. So here, you see, in this question, there's no explain. They didn't ask you to explain. You don't have to do any explanation. Okay, so what gravitational force? Yep. Acting on the diagonal position A, B, C. Okay, there's something wrong with this diagram. There's something wrong with this. What's wrong with this? Yeah, I don't know who wrote this, huh? Anyone? Do you copy this? You copy this wrong. It's it's a straight line. So who wrote this one? Okay. Straight line, alright? Straight line. So they cheat your feeling. Okay, because gravitational force is the same everywhere. Everywhere is the same. But what is different? Gravitational potential energy. So gravitational potential energy. If they ask about gravitational potential energy, the first chart is correct. Okay, gravitational force, but this is gravitational force. So it's the same everywhere. Next. Okay, Ninja heated a beaker of water to find out how the volume affects the rate at which temperature increases. So predict the value of y. So basically the higher the volume, the temperature, the start temperature will be the same. How about here? Predict the value of y. Is it something like 45? 630 is 65, 50 is 50, 65. 40, right? Okay, equal is fine. How can we just conclude from the above result? So the question is this: if you have more water, right? Let me have the 5 minute. Wait, the volume of water at the start. Okay, so the less water there is, the faster it is for the temperature to increase. Okay, but what is the conclusion from here? I mean, you can just say that, right? The less water there is, okay. So the less water there is, the faster it takes to heat up the item. Next one. Why was there no reading at 30? How come there no reading? See, the temperature go up and then reach 100. Okay. Shouldn't this be 200 or 110, 120? Over 100. Should it be 105? Cannot 105? Why cannot? Why cannot? What? Because the temperature of water cannot be higher than 100, right? So why was there no reading? Now they're asking how come no reading. Now one possible reason is the water has all evaporated. Okay, why? Because you can see this is 100 degrees Celsius. It has reached the boiling point. Okay, already reached boiling point. No reading. No reading means what? No water. You understand? If there is water, will there be a reading? Yes, right? If there's water, the reading will be 100. But then over here, no reading means no water. Or you can say someone took away the thermometer. But you are not going to get answer for that. Okay? Right? So since no reading, that means the water has evaporated. Okay? Yeah, all the water is gone. I know it sounds a bit weird, but all the water is gone. Therefore, there's no reading. If there's a little bit, you can still detect the temperature. Okay, but this is all gone. This one. What happened to the temperature of the hot water in the test tube after some time? Test your hot water, test your cold water, right? Okay, so this hot water inside cold water, the temperature will of the hot water will decrease. And why will it decrease? Yeah. The hot water to the sea. Okay, that's all. What's the variable change? The lag, huh? Yeah, the change variable. There's only one change variable. Okay, the others remain the same. So the others remain the same, meaning the mass remain the same. Then it is a fair test. If you have too many variable change, it's not a fair test. Got it? Right? When only one variable change, then everything remains the same, then we call it a fair test. Okay, next, what's the relationship between x and the number of times the wheel speed? I think it's easy. The longer the elastic band x, the more it speeds. Let's write it down. that is the more energy. This energy conversion. From the third diagram, release the band. You release the band. So what kind of energy is in the stretch elastic band? Yeah, elastic potential. Okay, so here is energy. So what energy is when the band is released? Kinetic record starts spinning, and the spinning wheel again, kinetic energy. Okay, so that's it. Right, so this is not the so we have 2 more minutes, we can try